refresh your memory. So I will only mention the key ideas. And so we want to take a look at what is probability, and we want to define ideas disjointness and statistical independence. And we want to talk a little bit about random variables and distributions. And we will take a look at 2 or 3 major distributions, kind of a review. And then we will talk about stochastic processes. So basically Markov and Poisson processes. So let us start with the basic ideas. Probability of an event. And here is actually probabilistic methods can sometimes require very careful thinking. So one needs to be very careful when you are using probabilistic methods. So probability of an event, I guess I'm using just P in my notes, so I will definitely do that here. Probability of an event A. Now here is a simple definition. If A happens n times, and if A occurs n times out of n, equally likely outcomes. And probability, you know, it is always a number between 0 and 1. So 1 means probability, when you have certain probability that something will happen. And of course, here are a couple of examples. You roll a die, which is similar for dice. What is the probability that the outcome is going to be odd? So your event is odd, and as you know, there are 6 possible outcomes, and 3 of them are odd, so here is 0.5. Now this involves some assumptions. Here we are assuming that that is a good, fair die. If the die is loaded, so sometimes people will make some dice which are loaded, so when you roll them, a certain number is more likely. So if it is a loaded die, then maybe probability that it is odd may be slightly different. And if you didn't know anything about a die, your normal assumption would be that it is not loaded, it is a good die. But if you knew that it was loaded, then probability that it will be odd could be slightly different. Maybe it could be higher. And remember that probability arises because of lack of information. So if you have the complete information, things are no longer probabilistic. So for example, you roll a die, and because you have a number of random things there that you can't track, but let us say if you have a mechanism for rolling a die, maybe you have some mechanical thing, and if you can precisely calculate the physics involved, then you can actually make a very good prediction of what the outcome would be. And in that case, depending on what you know, the outcome of tossing a die may not be that random, or the probabilities may be different. So if you know more about some event, the probability of that event is different, right? So, okay. And let's see some more basic ideas. A lot of good examples of in theory of probability comes from rolling of dice, and because theory of probability, it actually got started by somebody who was interested in gambling. I guess I don't encourage people to gamble, but I guess if you are going to be investing in the stock market, which you are going to be, because that's a good part of the whole economy, or if you're going to be buying a house, or if you are going to be getting some medical treatment, you're always to some extent gambling, right? Because there's always some uncertainty. Anyway, so probability of union of two events I'm using just P. Let us say we have two events. Probability that A happens or B happens. That is given by, as you know, probability of A plus probability of B. And of course, we have to exclude what we have counted twice here. Probability of A intersection B. And of course, here is your diagram. So let us say this is your event A and this is your event B. Then probability of A union B, this is A union B, is equal to this probability plus this probability. And of course, you have to subtract this because you don't want to count it twice. And here is an example. Here, the roll of a die. Okay, what is the probability that the outcome is even or the outcome is less than or equal to 3? And so that is equal to probability that the outcome is even plus probability that the outcome is, oh, I'm sorry. Yeah, I guess that's, I could put them in parentheses. Probability that the outcome is less than or equal to 3 minus probability that it is even intersection outcome is less than or equal to 3, right? And that you know that is of course half. Probability outcome is less than or equal to 3, so we have 1, 2, 3, 4, 5, 6. So that is half, or 3 by 6, 3 by 6 minus, what is the probability that it is even and the outcome is less than or equal to 3? 1, that's not an even number, right? So 2, that is an even number. So what is the probability that it is even and less than 3? That is, what is the probability it is 2, right? And that is 1 by 6. So that comes out to be 5 by 6. Now let us come to the idea of disjoint. two events, if A and B are disjoint, that means in terms of set theory, X intersection B is empty, then we have probability of A union B that is equal to probability of A plus probability B. So if they are disjoint, then obviously probability of A intersection B is 0, and so you can split the probability into two clean parts. And of course, here is one that is sort of obvious. Probability that event A does not happen, sometimes people use this notation, probability that A does not happen is equal to 1 minus probability that A happens, right? Okay, now let us come to a conditional probability. Probability of A given B. This means probability of event A given that we know that B has happened. And that is given by probability of A intersection B divided by probability of B, and of course that assumes for probability of B greater than 0, because when probability of B is 0, it doesn't work because you cannot divide by 0. Okay, now let us talk about independence. If A and B are independent, then, okay, what is the definition of independent? So if they are independent, that means happening of A does not affect in any way happening of B. Then probability of A intersection B, A and B are independent, then we can write them as probability of A multiplied by probability of B. Now I learned about independence the hard way. When I was a student, I once went to Las Vegas. How many of you have been to Las Vegas? You haven't been to Las Vegas?
No.
Oh, how come?
How come? Guess I'm bad in predicting and gambling.
Oh,
so
how come you haven't been to Las Vegas?
It's just that I've been here for 1 year. Like.
Oh, I see. Okay. Yeah, Las Vegas is a fascinating place. Yeah, it is a Sin City, of course, as you know. But anyway, so yeah, actually it is a fun place to visit, and it turns out that you actually don't have to gamble to enjoy Las Vegas. So you can walk around and see the lights, and but anyway, so when I was a student, I went to Las Vegas, and they have this thing called Wheel of Fortune. So in the Wheel of Fortune, you bet on a certain number, and then they roll a wheel, and then depending on which number you have put in, then you